should
got
make a
playlist
song
with the
like
bands.
that.
Plug into some.
Hey, we got you an extra.
Good.
What kind of music they got? Y'all could play?
I'm a teacher just like you. I teach sixth grade science, and if you're anything like me, you've wasted your playing time trying to find a video from
Childers, you learned anything?
Nope. That is the most informational video I've ever watched.
Hey, it's so nice.
What's a polygon?
5 angles.
A shape with lines that connect.
Now, both of them said that. And they're both wrong.
Oh.
What are the sides of a polygon?
I don't know.
You draw a polygon, what are you drawing? What are the sides? Not lines. They're segments, thank you. So it should have said segments that connect instead of lines. Both of them said that. Of course, those are probably for like, I don't know, those kids look like they were probably in what, 5th grade, 6th grade maybe. So they were for younger kids. They're not teaching them all the stuff that you're supposed to be learning in here. So segments that connect. Again, if you didn't write this stuff down in your notes the last class when I wasn't here, then you should be writing it down now. And all that really means is that the shape has to be closed. It's got to be a closed shape. What else?
That's 5 angles.
Maybe.
Segments.
Maybe. Put those two together. Does it have to have 5? But it has the same number of angles and segments or sides. So same number of, does everybody know that's a number symbol? Angles and sides. How many sides does it have to have? At least 3. It's got to have at least 3 sides. Ignore that stray part going up there that says at. Give me something else. The first one told you most of these. And the verse, is that what it's called? I'm not a music teacher. The verse, is that what you have when you repeat it throughout the songs?
Chorus.
The chorus, my fault. All right, see, that's why I'm not a music teacher.
You should be.
I don't remember the first.
You need very one.
Let's go. What else? What can it have? Make a guess. I'm not gonna make fun of you. Your name's Jaden, because you were messing with me earlier about being the stupidest thing you ever seen in school. How you doing, Andrew? You good? What can it have? What can it not have?
It can have sides that connect.
It could have 11. We could get as many as we want. Good guess, though. What shapes? Give me a shape that's not a polygon.
A circle.
Circle. What's it got?
No angle.
No angles.
Okay, because it's got what?
Curves.
Curves. No curves. What else can't the sides do? If I draw this, is this a polygon?
They can't
You
cross.
can't intersect.
No crosses. First one said no crosses. Is this a polygon?
No, that's to do
So it's got to be what? 2-dimensional. 2D. It's gotta be two-dimensional. What's it mean to be two-dimensional? A lot of students don't understand the difference between two-dimensional, three-dimensional, so on and so on. What's it mean to be two-dimensional? Exactly what the name says. I've told you all year long, math people, not very creative. If it means two-dimensional, it's got what?
2 dimensions.
2 dimensions. A length and a width. Alright, it's two-dimensional. So if it's two-dimensional, you can draw it where? On your paper, because your paper is two-dimensional. Alright? Length and a width, the base and a height. So it's got 2 dimensions, that's it. Anything else? Types of polygons. Different types of polygons. 3-sided. What's a 3-sided polygon?
Triangle.
Triangle. Fill it in. Fill it in on your paper there. Triangle. 4-sided.
Quadrilateral.
Thank you. Quadrilateral, or some books now call it quadrangle. How come it's quadrangle?
It has 4 angles.
4 angles. All of these, we look at the sides more than we look at the angles, but all of them are named according to how many angles the shape has. All right? Where do you think the name triangle came from? Tri, what's tri mean? 3 what? Angles. So this means, quad means what? 4 angles. Alright? So you guys are telling me I should never ever put music on my slideshows again?
You definitely should. This is good.
More fun.
Well, then you guys gotta be able to handle it. Alright? Because I have music on a lot of them, but I can sure get rid of it.
You don't.
Pentagon. What's penta mean?
5.
5. And gon, can anybody guess what gon means?
On the sides. Angles.
Angles. 5 angles. Every one of these is that way. So what's hexa mean? 6 angles. Then 7. 7's a little different. Does anybody remember what a 7-sided figure is?
A heptagon.
Heptagon.
Or septagon.
But some books now call it a septagon. Why do you think they call it a septagon? So you can match it up easier. Septa, 7.
But
S and S.
But like the prefix sept, like September isn't the 7th month.
September's not the 7th month?
No, like that's
Really?
No, it's the 9th month.
Is it?
It's because they added it.
What month we in now?
October.
October. October's the what number month?
10.
The octa means what?
It's the first couple months
8.
were originally there.
Well, that's stupid. Why is that?
Because the first couple months weren't actually there, like originally. They added them.
Not necessarily the first couple, but they added 2 months. Anybody have any idea why?
No idea.
Used to be that they thought that the 10 months was a year. What do we base a year on?
The sun rotation.
1 rotation of us around the sun, right? 1 rotation of the earth around the sun. Well, guess how long it takes us to rotate around the sun? 365 days, 12 months. They used to base it off of 10 months. So if you were alive back then it would have been January 1 year would have been really, really cold like it is now. Then when you were 25 or something, it would have been middle summer. So they figured out that, hey, to keep the months consistent, there should be 12 of them. So they added in 2 more months. And that messed up then the names. October used to be the 8th month. Now it's the 10th month. Nonagon. Nonagon we don't use very much. sides, 9 angles. What's a 10-sided figure? Decagon. What's deca mean? 10. Anybody have a guess on? Most of you probably wrote it down last time. 12-sided. I skipped 11. Any idea why I skipped 11? We don't use it. Alright? We don't probably use 12 either, but I put 12 on here just to let you see how these names came up with. What's a 12-sided? It's a do, deca, gon. What's do mean? 2. What's deca mean? 10. What's 2 and 10? 12. Could we come up with a name for an 11-sided and a 13-sided and a 14-sided problem? Do you really want to?
No.
No, because the more you come up with, the more you need to remember, right? If you remember these, the first 10 here, you're probably all right. 12-sided wouldn't hurt anything. If it's got any more sides than that, instead of trying to remember names for every possible shape, because could I draw a shape that's got 75 sides? Yeah. So instead of naming it with some special name, I could just name it, and this is what this last one says, I could just name it just with the number of sides, which is in, and then gone. So 75, gone. You just name it with the number and the, it's not called a prefix. Prefix is out front. What's at the end? Suffix. With the suffix of gone. If you didn't fill in what you need to fill in on this, when we're dealing with polygons, if you're looking for the perimeter, just add up all the sides. Just add up all the sides. Most every polygon's got a formula to find the perimeter of it. What is perimeter, first of all? How would I find the perimeter of?
Add all the sides.
What's it mean for the perimeter? If I find the perimeter of that pentagon, what am I looking for? The distance around the outside. Where in the real world might we use perimeter?
Like fence and stuff.
Making a fence or building the outside of a house if you're laying the footer or something for a house. Alright, so perimeter means the distance around the outer edge. Easiest way, again, add up all the sides. Find all the sides, add them all up. There's formulas for every one of them. You could look up a formula online for any polygon, a pentagon, hexagon, octagon, whatever it is, and use those formulas to find the perimeter. You probably don't want to do that. It's just a pain in the butt. So just add up all the sides. When you're doing it, if I told you that all of these were all the same,
Pardon this interruption. Would the golf team come down and get ready to leave, please?
and this was 10 centimeters, what's the perimeter of this shape? 50. And when we do our units, the units are just the same as the lengths. Alright? No squares or cubes or anything special. It's just centimeters. Because all you're doing is saying, alright, Logan, if you start walking here and you walk all the way around this shape, you walked how far? 50 centimeters. With a circle. Circle doesn't have a perimeter, but perimeter is sort of the same thing as circumference. Some books now, and this bothers me because that's just, Audrey, it's just telling you that they think that all of you younger people are stupid now and you can't understand it, so everything's got to be made real simple for you. And that drives me nuts. It should drive you nuts more than it drives me nuts that everybody and all people my age think that you're all a bunch of idiots.
You think you guys are a bunch of idiots?
I know.
She goes too late.
But you think we're idiots for different reasons. They just think that you're dumb and can't learn something, and I don't buy that. So you don't think that I'm dumb and can't learn something, you just don't like what I do.
You got to grow up, you got to tell different.
So circumference is the distance around the edge of a circle. Alright, so it's this distance. Distance around the edge of that circle. C stands for circumference. There's two different formulas for circumference. Diameter times pi, and then 2 times radius times pi. What's a radius of a circle? Goes from the center to the edge. Make sure you know that. Radius goes from the center to the edge. What's a diameter?
One edge to the opposite.
Goes from one edge to the other edge, but it has to do what?
Go through the middle.
Go through the middle point. It's got to go through the center. Alright? What do you know about the radius and how it's related to the diameter?
Half of it.
Alright, so diameter has to equal what? 2 times the radius. Write that down on your notes somewhere. Diameter equals 2 times the radius. That's the reason that there's two separate formulas. It doesn't matter which one you use. They're both the same formula, just written in different ways. Maybe Grace doesn't like this formula for whatever reason. She doesn't like the letter R. So she wants to use this one. Well, if they give her the radius, then all she's got to do is double it to find the diameter to plug into the other one. And again, that's just the distance around the outer edge. So your units are just regular units, centimeters, feet, inches. No squares, no cubes, nothing like that. Area. Area is always given in square units. The reason it's always given in square units, probably back in like 3rd, 4th, 5th grade or something, they asked you to find the area of this rectangle. What did you do?
Count.
You counted the little blocks. And those little blocks are squares. Alright, and that's why it's square units. How many, what you're figuring up when you're figuring up area is how many of those little square units will fit inside that two-dimensional shape. So if we were doing our room here, we would just count these little tiles. Now the bad thing with some of this is, what's wrong with these tiles up front here? They're only like half a tile or a third of a tile or something. We'd have to figure that out. And some of you back when you're in 4th or 5th grade, 3rd grade, whenever you did this, you had a triangle like this, you figured out, hey, if I put this little piece and this little piece and this little piece together, they make one whole. And then you got closer to what the area was. And we could still do that, probably don't want to. With these formulas, this symbol here is a lowercase cursive L, so that just means length times width. Most books now use this formula. Area equals base times height. Length and width, base, and height mean the same thing. No difference. In this rectangle, which side's the length and which side's the width?
No. That side is the length.
Is that the way it is? Doesn't matter. Makes no difference. Alright, it doesn't make any difference which one's the length, the width, which one's the base or the height. With a triangle, couple of things with the triangle formula. I'm going to write it over here. I'm going to write this formula 2 different ways. Most of you probably don't like the 1/2, so let's change it. What could you change 1/2 to?
0.5.
So put 0.5 times base times height. Write that on there. That's just an easier way maybe to write that formula. It might be easier for you to plug it into your calculator, do whatever you need to do. The formula I like the best is this one. This is just another way for a triangle. So write this with triangle also. Is base times height divided by 2. If you have your calculator and you hit base times height divided by 2, you can type it all in as one thing like that, and it makes it easier. You don't have to worry about trying to find the ABC button or anything else. Area of a circle. This is pi times radius squared. I didn't say this on circumference, and I probably should have. Somewhere on your calculator, you got a pi button. So make sure you can find that pi button on your calculator and use it when you're doing area and circumference of a circle. Is this formula the same as the formula for the circumference where it was 2 times radius times pi? Does 2 times radius mean the same thing as radius squared?
Yeah.
No, let's see. I think this is the radius here. About how long is that radius right there? Looks like it's 3 units long. So if that was 3, if I stick 3 in here, what's 3 squared mean? 9. What's 2 times 3 mean? 6. Are they the same? So don't get them confused. Alright? Don't think that 2 times the radius is the same as radius squared. Don't mess them up. Make sure that you don't make that mistake. In a triangle, draw this in your triangle. Doesn't matter which side of this triangle is your base. Makes no difference, alright? The base doesn't always have to be the bottom. So if I say that this is the base, draw that right there on your triangle. That's the base. Ignore this. This is not part of what we're doing right at this second. What's going to happen, or how you're going to find the base of a triangle, how you're going to know which side is the base of the triangle, is they're going to draw in something like this. And it's going to have that little right angle symbol with it. So draw that in. That's the height. The height is always that segment that's inside. It doesn't have to be inside. It could be on the outside. But it's the side that has that little right angle symbol with it. And the base is always the side of the triangle where that little right angle sits. It's the side of the triangle where that right angle sits on.
So there's a triangle inside the triangle.
So there's a couple of triangles inside the triangle, yeah. Now it could be that when they have the triangle too, the height could be given outside. They might do something like this, and I didn't draw it very well. They might give you the height, tell you that this out here is the height, right? So then you'll have to figure out something else. I didn't draw it very well. That's terrible way to draw it. But height, base. Again, does it really matter which one's the base and which one's the height when you're doing the math? No, because you're just multiplying them together. Write this down. What formula is this? Distance formula. We're going to watch this other video real quick. Just listen to this guy. He sort of explains it. Folk will probably think that he explains it better than Ebersole, so it'd be a good thing just to hear him instead of Ebersole. Let's see. Other options. Oh, that's not what I want. This guy's not quite as childish, so might be a little better off. Thank you. You guys see that all right? We need to have the lights off again.
Turn them off.
To find the perimeter of a polygon on a coordinate plane, start by determining the lengths of its sides. Because segment AB is vertical, we can find the length in 2 ways. One way is to calculate the absolute value of the difference between the y coordinates of point A and point B.
Don't
The
do that.
second way is to count the units on the
Do
graph
that.
from point A to point B. Segment
You don't mind
AB
counting,
has a
right?
length of 7 units.
So just count.
To find the length of segment BC, substitute the coordinates of points B and C into the distance formula. The length of segment BC is approximately 6.4 units. Use the distance formula to find the length of segment AC. The
Everybody
length of segment
remember the
AC
distance
is
formula?
approximately 5.8 units.
It's written up there on the
Finally,
board, make sure you
add the
remember how
side
to plug
lengths to
in.
find the perimeter. The perimeter of triangle ABC is approximately 19.2 units. To find the area of a triangle on a coordinate plane, select a side to represent the base. Because side AB is vertical, use it to represent the base B. We previously found that segment AB has a length of 7 units. If the base is segment AB, then the height h is the distance from vertex C to segment AB. Count units to find that the height h measures 5 units. Use the formula for the area of a triangle. The area of triangle ABC is 17.5 square units.
Braylon, you wanna do me a favor here in a minute? Go back here. Flop this around and I'll explain to you how to do it, once I get done explaining this. How come they use this as the base? Because it is vertical, makes it easier. If this is vertical, if the base of my triangle, this is the base of my triangle, and it's vertical, something that forms a right angle with it has to be what kind of shape, or what kind of special segment? Horizontal. Alright, and that's where they're going to form a right angle. Now, if they're vertical or horizontal, what can I do to find the lengths? Just count. I don't need to do that big long distance formula. So if you can do it that way, that's great. If not, then we got to use the distance formula to find all those things. But if you can pick one out and say, hey, I want this to be the base because it's vertical, then horizontal is going to come right into here and form a right angle right there at that corner, and I can just count both of them to find the base and the height. All right, Brendan, we hop back here. All you're going to do is minimize this. I might be able to do it here on the. Yeah, I did. You'll have to hit this for me. Hit the top button up there that closes it. That X. And pull up the PowerPoint for me again. Go down to the PowerPoints down at the bottom. Yeah, that one. Thank you, sir. Oh, I'm sorry. Do me one more favor. Pull up the, close this, or you'll have to minimize this. Here, I can do it here. Pull up the camera for me down at the bottom. And now pull the PowerPoint back up. And just go up top and hit slideshow over to your left. Left, right in the middle, there you are. Click on it and from current slide. Current slide, second one from the left. There you go. Thank you, sir.
You did a great job.
All right, so if you're on a coordinate plane and we're looking at this triangle and we want to find the perimeter and we want to find the area, what's going to make this triangle sort of easier than most of them? What's true about, let's do the perimeter. If we're trying to find the perimeter, we got to find the length of all three sides. Pick me one of the sides.
The bottom one.
No.
Name it for me.
NT.
NT?
Yeah.
Up here. So if we want to find NT, what's special about NT? You
National
can just count.
That's not special.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the length of it. If you're doing this problem, Lucas, is on a test, and you write down NT equals 9, you're going to get some of the credit. What other segment's pretty easy to find?
Bottom one.
TB. So let's find the length of segment TB. How can we find it?
Wait, but
How long was it?
at B it doesn't like go through the whole thing.
Yeah, it is. It's right there.
No, it doesn't. Like the line goes through that square right there. Above.
But it's only far inside that square.
But we're just finding the length of this segment.
Oh,
We're not finding anything else yet. We're just finding the length of that segment. So how long was it? 6. Now the bad thing here is, can we do the same thing for NB?
No, periodic. There you
What's
go.
he even saying?
We got to use
The distance
the distance formula. Alright, and to use the distance formula, we'd have to find the coordinates of these 2 points. Now that's if we're wanting to, Colton. That's if we're wanting to find the perimeter. What if we're wanting to find the area? Do we even need the length of this side? No. We can make this the what? Base, and this the height, or vice versa. Alright? Does everybody have the distance formula down there? Now, what Colton was trying to say before is you could use Pythagorean's theorem to find the length of that side, right? And we could do that to find it, but if we don't need it, no reason to go through and do it. On this, we're going to do this together. How are we going to find the lengths of those sides? Thanks.
We can look at look at
Beautiful.
Yeah, it is.
No, it's not.
look at like the numbers, like the coordinate numbers, and
Use what? How many times are we going to have to use the distance formula if this is a rectangle?
4 times.
Twice.
Maybe 4, because
No,
we'd have to
twice.
find all of them, right?
Twice.
But since it's a rectangle, what do you know about it? What do you know about this side and this side? They got to be the same, this side and this side? So do we really need to do it all 4 times? Just 2. So let's do it 2. Pick me a side. Say it again. DC. So DC. That's right here. For D and C, what 2 points are we going to use? Or for segment DC, what 2 points are we going to use?
1, 7, and 5, 3.
This is X. This is a X. That's a Y. Put that on your paper there. With this, again, unlike with some of those problems that we did in that first chapter, do we have to worry about the order? For distance formula, you don't have to worry about the order. Your distance formula every time is going to look like this. Have your calculators out, and everybody should have your calculators out. If you don't have a calculator, there's a white box sitting right back here. Get one. Your distance formula is going to look like this every time. Everybody should be punching this into their calculator, because if you're doing it wrong, we need to know it. Some of you didn't understand that with the first test, and then every one of these problems, you screwed them up. What's my X's this time?
1 and 5.
1 and 5. What's my Y's?
7 and 3.
7 and 3. Remember, doing this, all you're going to do is type all of this underneath the square root symbol in, parentheses and all. Don't type in the square root symbol, just everything underneath it. So parenthesis, 1 minus 5, close the parenthesis, squared, plus, parenthesis, 7 minus 3, close the parenthesis, squared. What'd you come up with?
32.
32? Anybody else get 32? Give you a second just to make sure everybody's getting it. They make you get up out of bed. You were going to try to sleep in, and they said absolutely not to get out of this house.
Yeah.
That's what my mom always was.
Oh, good. We're trying to get on the bus.
I'm more interested in.
Everybody get 32? Now, what do we do once we have that? Take the square root. Somebody help me out. What's the square root? 5.7. Anybody else get that?
Yep.
So how long is segment DC over here? 5.7. What else do we know in that picture then?
AB is 5.7.
So this side over here, so label it 5.7. What else do we have to find the perimeter? Is that enough?
No, we need more.
What else?
AD.
AD. So we're gonna find that side. So write down segment AD. Notice, how come I'm leaving off the segment symbol? Could I put it on there if I wanted? Yeah, you could. Is there any real reason to? No, because if we're finding a length, it can't be a line, it can't be a ray. Draw your distance formula again. For A and D, that's an X, that's a Y, we already labeled those. So what's my two X's?
-4 and
What might make this easier?
1. 1 plus 4.
1 and a -4, right? Because what's going to happen here?
Plus.
What else? What's my Y's? 7 and 2. Type all that into your calculator. Colton, open up your calculator, it's getting lonely. Quit turning around.
Alright.
Please make sure too on the first test, I've seen some of you, we don't do the square root right away, right? And some of you forgot to do the square root. So you put down like your answer for this first one. Seen a lot of people put down their answer was 32. That's not your answer, it's a square root of 32. What did anybody get this time? 50? Is everybody agreeing with that? Then what do you have to do?
Square root.
Take the square root of that. What's the square root of 50?
7.1.
So how long is segment AD?
7.1.
What else does that tell us? Now this problem's taking us like 6-7 minutes. Should it really take you that long? No, it's taking that long because Ebersole's got to hear himself talk a lot and explain it over and over and over again. What do we do to find the perimeter? Add up all the sides. So 7.1 plus what?
7.1.
Plus what?
5.7.
Plus what?
5.7.
Add all those up for us.
I got 25.6.
25.6.
Yeah.
Is that what we're going with, 25.6? Now this time they didn't tell us any units. If they don't tell you units, then just write this. Units, is it units squared? No, it's just units. Alright, so if they don't tell you units, just write units. How are we going to find the area? What's the formula for area of a rectangle? So base times height, could be length times width, either one. What's the base of this rectangle?
7.1.
Does it matter? No, it makes no difference. So base could be 7.1. What's the height? 5.7. Multiply those two together. 40.47. Anybody else get that?
Yeah.
What's our units?
Units.
This time it's units, ignore that, squared. So if we went through here and we counted all these little squares, how many of them should there be? About 40 and a half, somewhere around there. So watch, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. What's that tell us about all these other ones? Those two together probably make 32. Those two together 33, 34, 35, 36, 37, 38, 39, 40. Are we pretty close to what we said it was going to be? Yeah, so my slide switched. Next one, look at this one. A circle. What's the first thing we probably need to find on a circle? The diameter or the radius. Alright, if this is the center of your circle, they give us a point out here on the edge. How are we going to find, is that a diameter or a radius? How are we going to find that radius? By using what? Distance formula. So radius. Do I need to label those X's and Y's? Can you guys figure that out without switching them up and mixing them up? What's our X's this time?
4 and 6.
What's might make it easier? 6 minus 4. What's our Y's? 8 and 3. Punch that into your calculator. Let that high dollar calculator go to waste. Dylan, punch it in there, let's see it. Parentheses. See Cadence back there, she's letting her high dollar calculator go to waste. Come on, Cadence, help me out, man. Look. Why not? So help yourself out, man. Don't help me out. Just type into your calculator.
What'd you get?
27.
What'd you get?
27.
27? Anybody else get 27?
I got 20. I got 29.
29? Try it again, Cole, see what, maybe you just hit a button wrong or something.
Oh, I got 1 up.
Are you lying to me? Should I come back here and look?
That's the other one.
Yeah.
Well, no, that's the other one. Erased.
He did have 29.
Did he really? Alright.
I respect it. Thanks for backing me up.
So 29. What do we still need to do that?
Square root.
Take square root, what's square root of 29? 5 point what? 4. What's 5.4? The radius. So have we found the area or the circumference or any of that stuff yet? No. So we know this radius right here is 5.4. So let's find the circumference. What's the formula to find the circumference of a circle? Look back at your notes there.
Yeah. R squared. Or 2 times pi times R.
2 times
R times
r times pi. Now, most books, Audrey, you're right, you've learned it 2 times pi times radius in the past. In my notes, I turn it around because I want the radius to come before the pi. Doesn't make any difference. What is the radius this time?
5.4.
So 2 times 5.4 times pi. Grab your calculator. Somewhere on that calculator, there's a pi button. You're going to punch in 2 times 5.4 times, and then use the pi button. On the small calculators, I think it's on the, you gotta hit second, then it's on the right-hand side, is that correct? On the small calculators? Or left-hand side, I'm sorry. I don't know my right from left, Elena. Huh? Oh, you don't have to hit second on this, on those?
Easy to.
So it's just got a pi button? Yeah, the bigger calculators, I know you gotta hit it. What's it come out to be?
34.
What is it?
34.
Even?
It was 33.9.
33.9? Does everybody agree with that? What's our units? Is it units squared or just units? Just units, because you're just finding the distance around the edge. What else do we have to find? What's the formula for area of a circle? Look back at your notes.
Higher squared.
Pi times radius squared. What is the radius? Type all of that right there into your calculator. Pi, 5 times 5.4 times, and you could just hit times 5.4 again, or you could hit the squared button. What's that come out to be? Say it again.
91.6.
Or two different answers, so
I got 91.6.
91.6. What's our unit?
Units.
Units squared. That's the area. So I'm not gonna do it this time, but if we counted all these little squares, about how many of them would we come up with? About 91 of those little squares, 91 and a half. If you wanna do it, go right ahead, it's there on your paper. Andrew probably wants to do it, right, Andrew? Count 'em. Yeah, you do. I could tell by the look in your eye you wanted to count them all. Your problem, anyway, you got such a crappy attitude. What's that got to do with my classroom? Have I been a jerk towards you? Why do I come in here with crappy attitude? What if I came in here with crappy attitude and just took it out on me? Wouldn't that suck?
Do you have that motorcycle? I can see you on the harbor.
Colton, I'm getting ready to set you out in the hallway. I can see you out in the hallway sitting all by yourself. So focus. On this one, we want to find the perimeter in the area of this triangle. Let's deal with perimeter first. Let's give this some letters here. Write in these letters. N, T, H, S.
Whoa.
Write in those letters. We're finding the perimeter. Give me one of the sides that we got to find the length of. NT. Before I can find the length of NT, I need to figure out what? The coordinates. So help me out. Some of you find the other coordinates. What's the coordinates of N? We need to find all of the coordinates of all these points, so find them all, but what's N?
Negative.
Count it on your paper, it's easier. That's
Negative
the-
4 or 5.
Negative 4 or 5, everybody agree with that? Write that down on your paper there somewhere. How about T? Somebody help us out. Anybody else get 6, negative 5?
Yeah.
Yes? How about H?
Negative 8, negative 3.
Anybody else get that? How about S? Negative 6, 1. So we need all those. For NT, let's do this real quick. I'm going to put them up here, then I'm going to have you punch them in. into your calculator. First thing I'm gonna do is I'm gonna write this for every one of them. And let's just go with, give me the final answer. What's another side that we need to find the length of for perimeter? So we got NT, we found this one, or we're gonna find this one. NH. Give me the third one. HT. So we're gonna find the length of those, or yeah, the length of those three sides. I'm just gonna draw this for every single one of them so we can do this all as one thing, take care of all the busy work right off the bat. For N and T, what are the, if we're looking at N and T, what are the X's? -4 and 6, so I'm gonna turn them around, is that all right? 6 and -4, make that a plus. What's the Y's for N and T? That's gonna make that a plus, right? So some of you could be figuring that out, help me out for, I put NT, why'd I put NT again? That was supposed to be HT. No, I got NH. Sorry. Must just, unlike Jaden over here, I must like National Trail because I keep writing NT. So NH, what's the coordinates, what's the X coordinates for N and H? -4 and -8, so -4 minus 8, that's gonna change that to plus, that's a negative there. That was sort of hard to see, made my box, my thing too small. What's the Y coordinates for N and H? 5 minus a -3, ignore that stray mark going up through there, make that a plus. How about H and T, what's the X coordinates?
-8 and 6.
So I'm gonna turn them around, 6 and -8, is that all right? Change that to a plus. What's the Y coordinates?
-3 and -5.
So -3, ignore that. Make that a plus, so that's a 5. Type each one of those into your calculator, go ahead and find the square root once you do each one, and we'll just put the answers for each one down here so we can move a little quicker. Anybody figure out how long NT is yet?
Yeah, it's 14.1.
Colton, did you get that?
Yeah.
Liar. You gotta pick up the calculator before you can get it. 14.1, everybody agree with that? Is that for NT? Anybody find NH yet?
8.9.
Anybody else get 8.9?
Yep.
How about HT?
2.8.
2.8?
I got 28.
I don't know, help me out. Try it again. So HT,
Oh wait, yeah.
both of them seem awful long. 28 seems too long and 2.8 seems too short.
Yeah, 14.1.
14.1?
Yeah.
How are we gonna find the perimeter? Once you find all three sides, how do you find the perimeter? Add them all up. 14.1 plus 8.9 plus 14.1. Somebody do that for us.
37.1.
37 point what?
1.
And our units are just units. So that's the perimeter. How can I find the area? What two things I need to find the area of a triangle?
Base and height.
Base and height. Do I have either one of those?
You need to find ST.
This right here, that right angle symbol tells us that this is the base. That's the base. Well, we need this height right here. And we're gonna have to find that height by using the distance formula again, so that'd be ST, which is the height. Somebody help me out, what's the x coordinates for S and T?
-6 and 6.
So let's do 6 minus a -6 squared plus
1 and -5.
1 and -5. 1 minus a -5 squared, change that to plus. Type that into your calculator real quick. Remember, this is your height. Get it, Colton, or you just punching buttons on your
13.4.
13.4.
Yeah.
What's that
That's after you took the square root, right?
Yep.
So the height is 13.4. How are we gonna find the area?
8.9 times 13.4.
We want this as our base, 8.9, times the height, which is 13.4. Is that all we do? Divide that answer by 2. You can punch all that into your calculator just like that. Remember, for a triangle, what a triangle is, if I have this shape, a rectangle, and I don't want the whole rectangle, I just want like the triangle part of it, it's like you're taking half of it. That's why you're dividing it by 2. So what's it come out to be?
59.
Say it again.
59.63.
59.6. What's our units? Units squared. Again, that took us a while. Should it really take you that long? Now I'm sitting here explaining it and doing all this extra stuff and watching Andrew sleep and everything and wasting time. All right, fill in what you need to fill in on this. An equilateral polygon. What do you think equilateral means? Equal, what do you think lateral is?
Size.
Sides. Lateral means sides, so equal sides. What do you think equiangular means? Equal angles. So if a triangle, or I'm sorry, if a polygon is equilateral, that means all the sides are the same. All right? If it's equiangular, that means all the angles are the same. When a polygon is equilateral, does that mean it has to be equiangular? Or vice versa? No. If I give you this shape, and I'm going to let you guess, what do you think that looks like? Go back to 3rd grade again.
It looks like a rectangle, but we don't.
Looks like a rectangle, right? In a rectangle, what do you know about all 4 angles? They're all 4 right angles. They're all 4 equal. Does that mean all the sides are the same? So a rectangle is equiangular, but it's not equilateral. If a polygon is both of them, then it's called a regular polygon. Put a big asterisk beside this. This is very, very important. You've got to know that if a polygon is regular, because they're going to say given regular polygon, whatever, and you got to know that that tells you all the sides are the same and all the angles are the same. When you see a stop sign out along the road, guess what's true about all the sides?
Equal.
They're all equal. Guess what's true about all the angles? They're all equal. When you're looking at home plate on a softball or baseball field, guess what's true? All what's equal? All the sides are equal. Are all the angles equal? No. This angle and this angle are actually right angles. This angle down here is also a right angle. These two are not right angles. Alright? So it's equilateral, but it's not equiangular. A geometric model is a geometric figure that represents a real life object. We're just going to go through this real quick. I just gave you this because this is telling you where this stuff comes into play at out in the real world. When different jobs are doing different things, I know my father-in-law a few years ago had somebody come in and take out the big trees in his woods, and they paid him for it. Anybody ever have that done where they come in and they cut down the biggest trees, and or you see them hauling those great big huge trees away from a neighbor's property or something? They come in and they do those. Well, those guys that cut down those trees, they go in there, and what they do is they use geometric modeling. They probably don't know that they're doing it. They're just, we're taught what they need to do. They use geometric modeling to decide on which trees to take and what they're going to use those trees for, and then they separate them. All right? What do you think with a tree, and we're going to do it here in a second, if you have a tree here, what do you think they model this as geometrically?
Rectangle.
A rectangle. So and that's all it means. They use rectangles, and they might use a cylinder also if they're doing three-dimensional stuff to represent that, and that's all geometric modeling is. What could we use to use geometric modeling on this starfish here? Is a star a geometric shape? Is that one of the polygons we talked about earlier?
No.
What could we use? What if I did this? What shape do I have? Triangle. Could I do that for each of the stars' arms or whatever they're called there? So how many stars do I have? How many stars are there? 5? What do you notice about the middle? What shape is it? Look it up, it's there in your notes if you don't remember. It's a pentagon. Alright, so could we do that? Yeah. How about a bee? When you have a beehive, what do you notice about these beehives? What shapes are they? Hexagons. Anybody have any idea why bees make their hives hexagons? Any idea why these pencils are hexagons? How come they don't make pencils just all of them? Some pencils are made, they're round. How come they don't just make them all round? Fit your hand easier if it was round. What's it do when you make it? If you made them all round. What do you notice about this stuff in here? Be wasted, right? Wasted space there. When they're hexagons, guess what happens? They all fit together perfectly. Bees do it that way because they all fit together perfectly. If they made their holes round, there'd be wasted space in there, and they don't want that. What could we use to geometric model this tree here? Rectangle, what else? Maybe a circle, rectangle and a circle. Now, is it going to fit it perfectly? No, that's not what we're worried about. Last thing here, you want to frame this marvelous poster to hang on your wall. No. Colton will be at home tonight trying to blow it up and post it on his wall. What would you do to frame this? What would you have to find?
The right size frame.
hope that you can do it yourself. The length and the width. Do we know the length and the width? What else do we find? What are we going to find to frame it in? What is that called? The perimeter. So we need to find the perimeter. How are we going to find the perimeter? Add up sides. So just 1.5 plus 2.1. What else? Plus 2.1 plus 1.5. Add that up for me.
7.1.
What is it?
7.1.
7.1. What's our units? On 7.2.
Oh, my bad.
What's our units? Meters. What is that again for this shape? The perimeter. The perimeter. This packet I'm giving you, this is your assignment. Don't worry about the assignment on the other thing. This is sort of a combination of the last two assignments, dealing with the angles and dealing with polygons.
Well, it has my name on it. What is that?
Put it in my
The hair.
Lucas, it all makes sense?